So our speakers today are going to be, unfortunately, Ryan has the flu. He's the one in London. We'll be talking to him a little bit later with his partner Francesca from Qt Circuit. But I'd like to welcome Carlos Olguin from LogicInk, Sylvia Heisel from Heisel by Design, and Dr. Jess Jur from North Carolina State. We talk a lot about wearables and how we integrate them into our lives. And these three industry leaders and pioneers have figured out a way to not only integrate wearables into our lives, but to use wearables for fashion sustainability, finding new materials in e-textiles, and finally using our own skin and biology and actually making the technology disappear. So if I could please welcome to the stage Sylvia, Carlos, and Jess. So first of all, would you please introduce yourselves and just tell us a little bit about what it is that your company is doing? Just tiny, tiny bit.
Sylvia, go ahead.
Hey, good morning. I'm Sylvia Heisel, and my company, we work between fashion and technology. My background was in fashion, and then about 10 years transferred into technology and product design for wearables, and now I find myself back in fashion.
Good morning, everybody. My name is Jess Jur. I'm a faculty member. I'm an associate professor at North Carolina State University in textile engineering, chemistry, and science, where I run a research program on wearable technology, specifically in garments and other textile form factors. And then I also run a design course in which we interface students with industry to do product development. We don't have I guess our main product is your future employees.
No, not right now. Great, Carlos?
Hi, my name is Carlos Olguin with a G, not a Q. And I'm a CEO, co-founder of LogicInk. We're a San Francisco-based startup making the next generation of wearables. These are non-invasive tattoo-like devices that are applied like temporary tattoos and visually transform in shape or color to alert you of a condition of interest in your body, like hydration levels, or in the environment, like pollution levels around you.
Great, thank you, Carlos. And Sylvia, we're going to start with you.
Okay, good morning. So, as I said, I started my career in fashion as a designer and then moved into product design for wearables and connecting fashion and technology. And 2018 was my year of going back to fashion. And that happened because the fashion industry kind of came to me. And the two big buzzwords and trends in fashion were technology and sustainability. And so I started working with fashion brands again, and I wanted to share a little of what I learned. The first thing that came up that was really like hit me in the head was that fashion brands were coming to me going, okay, we want to make a smart product. We want to incorporate technology into our fashion pieces. And I'd be like, okay, great, we're going to make a wearable. And they'd be like, well, everything we make is wearable. We don't understand what you're talking about. They want smart. They want incorporation of technology. They want this, but they don't understand what a wearable is. There needs to be some kind of coming together of that. The next thing that I learned that was to me really interesting and was different than when I was in fashion 10 years ago is that the young luxury consumer, it's about, brand and what the brand represents, as well as what the product is. They're not looking necessarily for the coolest looking or the best. They're looking for the whole picture of what they wear represents who they are and their values. And that's where sustainability has really come into the equation. So a lot of the fashion brands are looking to technology for how can I be more sustainable? And sustainable is this big, messy thing, and there is no answer. So a lot of what fashion is looking at is how can you make a cradle-to-cradle product? And how can we create a circular economy where we're not just depleting everything? So a lot of as I'm working with fashion brands, what we're doing is we're using technology, we're taking all that data that they've been collecting and going, okay, let's look back, let's trace the supply chain, let's identify how we're making things, what materials we're using, trace it through using RFID or blockchain or just figuring it out and writing it down. And then let's the second thing is admit that consumers are going to end up throwing your product away. At some point, that product is going to be thrown out or recycled or something. So know what that is. Address how could you take it apart? Can it be recycled? What are the options? You don't need a solution, but you do need to accept that this is going to happen. Packaging and shipping also, I should have been here, are also really big areas of where there's a lot of room for a more sustainable option. And looking at what are you doing. So we've been taking all of that, looking at it, and going, okay, where can there be improvement? Where can there be use of new materials, use of new manufacturing, use of new technologies to make a more sustainable product? And then telling that back to the consumer, letting the consumer know and being transparent and making that imperfect story part of your story and part of your brand identity. The other thing we've been doing that I'll leave you with is to create prototypes of future products. So this is a 3D printed compostable dress that we did this year with the idea that in the future there would be perfect sustainable products that would be 3D printed with zero waste, worn, and then thrown in the trash with your vegetable clippings and composted. And I thank you.
Thank you, Sylvia. It's great. So, Jess, you're into textiles and sustainability, and you work with a lot of students. Where do you see them solving the problems that Sylvia posed?
Well, a lot of times when you're at a company, it's sustainability can be an afterthought, right? It could be a high risk thing that you don't want to necessarily put a lot of investment into. But I think that if you have that strategy, you're kind of missing the boat. If you don't design from the beginning with a sustainability vision in mind, then you're going to lose the consumer interest at some point, especially with how consumers are wanting to have their textiles and garments. So what my students have, and also at a company, you have typically blinders on. And so we, as the Wilson College of Textiles and NC State, we have sustainability as one of our primary goals. And we work with companies at the early product development stage, and then also kind of fill in that gap a lot of times to help them understand that this is a risk to take.
Yes. And Carlos?
Yeah, that's an important component of what we do. We're still very early stage, but just to give you an idea, most of what makes a LogicInk tattoo is not only sustainable, is edible, and that's an important choice that we've been making. So anyways, we're not fully there, to be honest. We've been focusing on first delivering a product, but it is clear in our goals to gradually become greener and greener.
So how many people in this audience are actually concentrating on the fashion side of wearables? Okay, a few. That's great. So does everybody, when Sylvia uses the term cradle to cradle, does everybody understand what that means? I don't either. Could you explain it?
Sure. The concept of cradle to cradle comes out of, I think, the Ellen MacArthur Foundation and a few other I don't know, a number of places, but the idea is that rather than goods that are created, used, and then disposed of and become waste, they're in a circle and they can be recycled, they can be taken apart. So you create something, you sell it, your consumer wears it, it gets taken apart or recycled in some way and back, so that you have a circular system without any, without any waste out of it. And there is in clothing right now, there's a lot of innovation in technologies to separate out different materials and fibers, so that when something goes to recycling, you're separating out the metals from the polyesters, from the cottons, from the same way you would the paper from the plastic in standard recycling. And then all those materials, looking to materials that can be reused or remade into new things.
Great, thank you. Thank you for explaining that to me. Jess, what do you have for us today?
Okay, so Julie asked me to talk about what the kids are doing. So we're going to talk about some of the new developments in textiles. This is some of the things that are coming out of my research group, but I think that it's answering the needs of the industry as a whole. So, what we're kind of focused on here is IoT of the body, obviously. Our goals for this particular type of product is data. 90% of the value I've heard is pretty much in the data that you're collecting, not necessarily in the product that you're producing. The big goal and the big hurdle for everybody is really the cost reduction of any of this technology, so that you can get it in the hands outside of that, that 2% population. You wanted to get it into 98% of the population. So there's a number of challenges that we'll address kind of as we go through the presentation. I didn't hit on sustainability at all, because Sylvia does a great job with that. The one thing I have to say though with sustainability is how important it is there's a lot of, post-manufacturing waste, as the garment's being produced, there's a lot of waste there. So looking at new technologies to reduce, like using 3D printing, that is definitely a sustainable vision just by doing 3D printing. So I don't know if everybody's familiar with the Gartner hype cycles. This is kind of where I see it. I would not take it with a grain of salt. So smart garments are kind of like going up between the technology trigger, and they're reaching their peak of inflated expectations. There's probably some products that are already beyond its peak. Most wearables are on the other side of the peak of inflated expectations, and I would have to say that there's a lot that have gone through the trough of disillusionment. And to get out of that, you have to really be able to make a viable product and what I mean viable is you have to be able to reduce cost and understand the real use case that you're going after. And so these are some of the things that my research group does. So we look at materials innovation. We look at materials that are available today that you can purchase pretty easily, and then we look at next-gen materials as well. And then we start to apply these into textile electronic systems, understand use case scenarios, and then also start to do a lot of the standardized testing. So we get a lot of our funding. I would say about 25% of our funding is from federal government, and the rest is from industries and companies up there. The red circle ones are actually technologies that have spun out of my lab within the past 2 years. So this is my research team. It's kind of a unique research team model if you look at it from a university perspective, but this is the way in which I do things. So we have PhD students and master's students that work on process and materials research. They're doing the innovation, and they have the blinders off, and they're doing the nitty-gritty stuff. But I also have a product development team, which consists of professional people with either master's degrees or have done some industry have industry experience, and then also master's students that are training in this process. And they give design specifications that makes the process and materials research that we do relevant. And I'll give you an example of a use case scenario development. So back in 2016, we did an I-Core program that was sponsored by the National Science Foundation, or it's a National Science Foundation program, in which you're tasked to basically fill out a business model canvas, and you have to interview over 100 stakeholders within about a 2-month period. And the technology we're actually doing was exploring a wearable garment, a smart garment that would be for law enforcement agencies. And so this is an example ecosystem that we actually go and talk to everybody in this ecosystem, try to understand this, try to find out what their pain points are, what's keeping them up at night. And the outcome of this is what happens is you get a specification document for what a particular product would be that has a nice value proposition. But importantly, you get a price point. And I can tell you the price points for law enforcement agencies are incredibly low. So we also go out and talk to the manufacturers and also the brands to figure out what are their, what's keeping them up at night. And production cost is always one of the bigger challenges. So exploring this, so this is Atho's garment, and this is a typical process on how you would make just about any wearable technology, or probably 95% of the wearable technologies out there. It takes a long time. It's a job shop type manufacturing process. It takes about 3 hours to make one of these garments, and the high cost for production results in a high cost at retail. Our goals and strategies are actually to reduce, within my research group, is to reduce this through automation. So getting rid of screen printing and reducing some of the annealing processes by actually doing all of this sort of an inline. So this is a direct write process. It's basically 3D printing of electronic materials on textiles. This is part of it, and we're actually doing this on one of the panel sections here. But then we go and we start to explore how do you actually design this. Sarah talked earlier about about function and fashion. So you have to make it fashionable, number one, but you also have to have good function and comfort. So we actually study the panel sections that are within this garment to understand, number one, how does that improve the functionality, but then also how does it improve the comfort. So we do this by actually understanding some of the wearability of these processes. And so this is an electrocardiogram shirt that we do a lot of research on. We do wash testing, we do the materials biocompatibility testing, some of the electromechanical analysis, and then we also do the human validation. So this is one of my colleagues, Edgar Labatten, who's an electrical engineering professor at North Carolina State University. And he's doing a number of different exercises. Those green shaded regions within the plots are actually regions in which there's data noise. And so we're trying to understand what's the relationship between the noise reduction and the ability to obviously get high quality data through redesign of the textile. One of the key centers that we have at NC State is called ASSIST. It's also funded by the National Science Foundation. It's an engineering research center. It's called the Advanced Self-Powered Systems of Integrated Sensors and Technologies. This is where we actually have the new specification documents for the products of tomorrow, especially in the wearable sector. We have a lot of collaborators. These are all of the different types of things in which we do research on. But we're essentially trying to make a self-powered wearable electronic. To do that, this is the type of specifications that you actually need. These are the ones that are in the red box on the right-hand side. Are some of the specifications. So we're actually having to get down to 50 hertz frequency or duty cycling in order to get for the ECG signals or for electrocardiogram. Our total power consumption on this is 180 microwatts for continuous range, or for continuous measurement at about a 3-meter range. So to study this, we actually have to understand how much energy can we produce and where do we produce energy. And so this is one of the platforms in which we've developed within my group, in which we harvest power at one location and deliver that power to another location through a power management units located on the shirt. For example, this is the type of data that we end up getting on this. And so we have shirts that we have thermoelectric devices that harvest power through the body's energy or the body's heat that it's giving off and the temperature difference between your body and the atmosphere around you. And we do 60-minute trial studies in which we get plots like this where we can study the person's activity level versus the temperature that's surrounding them. And we can map out how much energy that person can produce through a given day based on their activity levels. So for example, you are that bottom star there at the 20.5 degrees Celsius. And as you get up and move within this building, you're going to have higher activity levels. You'll walk around in different environments. And from this, we can actually plan out how you actually make a self-powered system. So that's some of the things that we're working on, and I think are answering some of the challenges for the industry.
Carlos, do you have any questions for Jess?
Yeah, it's fascinating, and I'm just curious if you have looked at, it's kind of a selfish question, but I'll ask it, colorimetric assays as part of your exploration and your work?
We have not. There's actually a faculty that's at Northwestern University, John Rogers. Who has done a lot of that work. We have started to do, we do a lot of, one of the new manufacturing techniques that we've been exploring is inkjet printing of our processes, so getting away from the screen printing or even this direct write, and creating conformal nanoscale coatings on the textiles. And with that, we've started to look at a lot of enzymes, which kind of go down that route towards assay analysis.
Makes sense.
It's interesting. Thank you, Jess. Did everybody follow all of those stats and what Jess was getting at? My biggest question for you, Jess, right now is, I've been doing fashion and wearables since 2011 when we did the first fashion show here. And I want to know what the difference is between the Hexoskin shirt from like 2012 and today. Where are the advances? What is advancement have we made, and where are we going?
Yeah, so I would say the primary advancement, if you're familiar with the Hexoskin shirt from, I guess it was back in 2012, 2013 timeframe, there was actually wires that go throughout the shirt. A lot of people are trying to get rid of those wires because, number one, it's a kind of makes it a kludgy product. I would say. And what they're doing is they're printing, like what we're showing here, they're printing the electronics within the garment. And the ink manufacturers are creating nice stretchable inks that you can actually apply onto the textiles, have good reliability over time, good washability. And that whole industry is really kind of founded and leveraged from what's happening in the print electronics industry for flexible electronics and flexible solar cells and all the money that's going into that. And so we're sort of now being able to leverage that in a much more, I guess, accessible way.
And how much is that going to save in the cost of the garment? I was talking to somebody downstairs yesterday, and they had a shirt that literally was $500. And great technology, but $500.
Yeah, that $500 cost is not necessarily materials. I can tell you that much. It's the manufacturing and how you have to assemble all of these panels. Literally, there's humans that have to do all this. There's how you place the electronics on through either through like heat press technologies or whatnot. I mean, that all has to be done by the human. The more that you can actually get that into the automated space, the lower that cost is going to go. And I would imagine that company that has a $500 shirt is trying to go that direction. If they're not, they should.
Right, thank you. Carlos?
I want to ask you too, with all the corporate partners that you're working with, what types of insights have you learned from them, you coming from the research angle?
Well, I talk to a lot of companies, and so this comment will be sort of not specific to the companies that I work with. I'll just have to make that caveat. There's a use case problem that is real. A lot of people are just kind of creating a garment and saying people are just going to buy this just because it's cool. That's not why people buy things. People buy things because they need it. And right now, there's a big misunderstanding about what people need.
Great, thank you so much. We are running behind. It's not because I talked too long, it's because we started late.
And I talk a lot too, so anyway.
Okay. Carlos?
Yeah, sure. So at any given time, we are constantly experiencing this range of conditions in our body or in the environment. They can have a tremendous effect in our health, but for the most part, they remain invisible to us, disconnected from our actions and behaviors. The current state of wearables is such today that, first of all, it's highly fragmented, at least as a product, as an end product. And devices tend to be these bulky gadgets that are strapped to your bodies 24/7. They tend to be very expensive. They tend to have a very high learning curve. And invariably, they require yet other devices like your phone or your computer to be able to be operated strictly as a requirement. This makes for a multi-sensing experience that, frankly, today at least, is either impractical or unaffordable for many. Yet many people still want to learn more about what's going on in their bodies or environment to live a healthier and longer life. And that's the opportunity we're addressing at LogicInk. At LogicInk, we make temporary tattoos or tattoo-like devices that are non-invasive. They visually transform to alert about a condition of interest in your body, like hydration levels or how much alcohol you drank, or in the environment, like pollution levels around you, or letting you know when you had enough sun for the day. The way we do this is by sensing non-invasively from your sweat, from volatiles that emanate from your skin microbiome, or from the environment. And we develop a process to be able to do this on a case-by-case and gradually building a platform, meaning depending on the condition we want to sense, we either use a responsive chemical system or we use a cell-free enzymatic system, like what Jess was talking about, printing an enzyme. Or we also engineer organisms. That's part of our expertise in our team of who we founded the company. We're excited because when you think about what that slide means, it's really a very, very small sample of what can be sensed in this way. In reality, the conditions that can be sensed are limitless. The applications are limitless. And we're starting this path in this direction that even though in academia there are people working on it, there's still a very, in our view at least, very strong bias towards electronics. And we're painting a future that is complementary to that, to electronics. The future of consumer electronics is electronics free. So, at the core at least. So this is what we've done. So far to date. So you can see here, I'll just play some videos of the work done. Some of this work has been validated by NIH, National Institutes of Health. In fact, on the top left is an alcohol tattoo validated by NIH. That means that some scientists at NIH had to get drunk to test that it worked, and so did we for research purposes. And we also have a pollution sensor, so it's a totally different system. It's a redox system that is sensing PM 2.5, which is very relevant for us in the Bay Area, but also in very polluted cities in Asia, for example, or in Mexico City, where I'm from. And we have more examples that we can talk to you later. But the other thing I want to also mention, and it's related to what Sylvia and Jess have been talking about, is that at the end of the day, this is something on your skin. And anything on your body, is intimately connected to your sense of self-identity. We don't take that lightly. We don't want to be a clunky medical device that you have to use because you have no choice. We actually want to embrace the current cultural conversation around body-based self-expression. That's why we chose this form factor that feels and looks like a tattoo. As you know, or you may not know, almost half of millennials have at least one tattoo. So again, we're riding on that conversation and looking to be both a conduit of health awareness, but also a conduit of self-expression. So just to ground this in terms of how this works, so first of all, it's not bound by electronics. So the logic is in the ink, and that's why the name of the company. And instead of looking to create a binary on-off change of color, we're using space as the second dimension to be able to program literally, initially at least, those same interfaces that you find on your phone, like energy bars, or on your Apple Watch, like activity rings. But instead, we're using chemistry or biology to be able to create those displays on your skin directly, fluctuating dynamically. So you can see, for example, in this case, the inner ring is a real-time measure, in this case, of how much UV you're being exposed to. And the outer ring, so the darker it becomes, the stronger the UV rays are. And the outer ring in this case, is a cumulative measure of how much sun you're accumulating over the day. So it's calibrated to change in color, like a little clock, that it's just moving clockwise. And when it reaches the end, it means that someone with sensitive skin had enough sun for the day based on data sets from the World Health Organization. That is honestly the most novel aspect in this particular sensor. But that same pattern of real-time versus cumulative is something we're using constantly for the other sensors, like pollution, for example, or alcohol. You can imagine in alcohol, for example, populations at risk, like youth, being aware of these feedback loops early on as they start drinking. The first week they took 2 drinks, and in a month they're taking actually 4, and that normally they don't have that exposure, and it's a feedback loop that is helping change or prevent lifestyle choices down the road that are not good for them, but also not good for the economy as a whole in terms of what it costs for the economy to be able to take care of those situations later. So the last thing I'll share before I show you a quick video is that you can imagine, the tattoo is the UI, right? So you don't require a device. It's disconnected and it works. At the same time, we want to harness those data sets. Those are unique data sets that can help the individual or the community of users as a whole. So what we've done is we've developed an app. We are working on it still. But it's just basically something that you capture at the end of the day. So you don't need to do it all the time because you're just looking at the tattoo. But at the end of the day, the tattoo is telling you a story of what happened with you and your health. And we want to make sure we understand that and we can interpret it in ways that are useful to you. For example, without fully being a medical device and making a medical claim, we can say things like, people who have been exposed to this much UV radiation or have drank this much fall under this risk bracket. And those are important feedback loops, again, that are being used with a lot of computer vision and AI in the app to be more quantitative than what you are just looking in a more qualitative fashion by just looking at the tattoo. And that's important as part of the future we're trying to build. So again, I'm not trying to be a radical non-electronics, person. It's really important for us too, but we believe that it should be disconnected. You should feel free to live your life as you normally do with your children, with the people you care for, the elderly, and not having to have a phone next to them at all times. And we also believe that at the same time we are, instead of transplanting your identity to the phone and everybody's looking at their phone, we are increasing the bandwidth of what defines yourself through tattoos that now have more things that say something about you and can be as private or public as you want it to be. For example, again, the alcohol tattoo that we've been working on, it can be something very public. You're in a party and you're the designated driver, or you're in a date and you're just looking at the back of your wrist and seeing something as opposed to taking a breathalyzer in the middle of the date. So I'm going to leave you with a short video, a 1-minute long video.
This is our first product, LogicInk UV. As you get more UV exposure, its user interface will transform in color. And when LogicInk reaches its end, it means that you've had enough sun for the day. We started with UV, and along the way, we've explored a range of sensors. For example, pollution, alcohol, pH, hydration, skin health that shows how dry, oily, or hydrated your skin is, high energy visible light, temperature, and also DNA. We imagine one day when people will be able to pick and choose a range of sensors and match them to a fully customized tattoo, making that experience for that person unique, being both a conduit of health awareness and self-expression. We want to think that we're increasing the bandwidth of what defines you. It goes beyond the current state of software apps. Now, the apps are programmed and matter on your skin, like these tattoos. And we think that's an exciting future.
So then, when you're finished with it,
That's it.
when you're finished with it, you have a snack, right?
Yeah, you deserved it.
So, Sylvia, do you have some questions for Carlos? You guys were discussing this a little earlier.
I think it's super cool. I'm really inspired. I guess as, you know, because I see tattoos as a part of self-expression and as a part of fashion. And so thinking of it as a fashion accessory, where do you see it going? Use cases.
Yeah, so I mean, we've talked a lot about that, and again, it's part of who you are in a perhaps more inherent way than clothing, because you tend to change clothing more frequently than a tattoo. And this is not a permanent tattoo, just to be clear. But I think so just to give you a use case, you know, we could imagine a future down the road where, you know, the tattoo is sensing things about you, but it could also sense things about the environment or about what your tattoo is also saying, right? So we started by mimicking just how software apps work, but there could be a future where, you know, true affinity in a date, for example, would be based on actual chemistry, and we will be able to learn, you know, things that are happening, and it could be enhanced by my app, for example, or not. And I could be learning something about you that you decide you want to share. And
So I could wear a different one each day?
You could wear a different one each day. Or you will, based on the time of the year, you will have, you know, different sensors coming to you that you want to assign to your tattoos. Those are the kinds of futures we imagine. We're not there, of course. But does that answer your question?
Yes, that's awesome.
So we do have a few minutes left for questions. So if anybody has any questions for our panelists, please raise your hand and we'll bring around the microphone.
Good morning. Dr. Chair, first of all, congratulations on getting through I-Core. I just went through that this past semester, and that was too much. So I'm over at Mississippi State. Being that you see that, and we've seen that the Gartner hype cycle, we see wearables going down, and we're looking at sports technology. We've talked with coaches. They're seeing, some of the schools have actually dropped using some of the wearables. Kind of where do you see the next step in actually getting back into these schools and professional sports organizations?
So you're talking specifically about fitness tracking for sports organizations?
Correct.
I think that's not Sylvia. Jess?
Yeah, so I would have to say that when you start introducing wearable technology onto, I mean, you're collecting lots of data. You have to have somebody that manages that data. You almost need almost like a data specialist on that team that is able to communicate with everyone else. I think it is having that multidisciplinary understanding of how you could use that data in an effective way to improve their performance. And so, yes, you can provide the wearable, but you also need to provide that extra level of understanding and kind of babysit that technology a little bit as it goes out into the athletic team. That's kind of my general take on it. Although I have to say I've done limited research on sports and fitness specifically.
Carlos?
Yeah, we've been working with a large company that is a sponsor of teams, and we're still in the process of figuring out how to work together. But what I can share is that, at least in the case of basketball, the little we've been exposed to, NBA seems to be at the front end of exploring the use of wearables, and things that they care, from what we know, are well, first of all, there's a wealth of data that they don't even know how to process. Right. So there's more data that they have the analytical power to understand. That's one. Two, they always want to tie, like Jess says, to performance, any data point that they want to understand. So that's kind of obvious. And then where we come into play is how do metrics like hydration, for example, which is one of the things we're working on, have an effect on not just performance overall, but let's say injury, which is a big metric on their scale of what's their bottom line. So the more we, like I'm just talking from my own perspective, the more we can correlate, day-to-day changes in relative hydration to changes in performance or changes in people getting more or less injured, that's where we see how we can pitch or establish a value proposition to these different groups. I'm just speaking what we're going through right now.
Of course, of course. All right, 0. We are out of time. However, we have a couple of great speakers coming up. 11 o'clock, we'll take a break. Our panelists will still be around for a short time, so you can ask any questions. I just ask, if you're going to have your questions right after the session, that you step outside. Please join me in thanking our panelists.